imaginary root. So 4q square is less than 1 implies q square less than 1 by 4 means q is less than half. Quality factor is not even 0.5, it's less than 0.5. So it means almost more than 50% of energy is lost. So hello everyone. Now as we have discussed in a practical manner that every oscillation is going to be in a damped manner. The amplitude is going to decrease, the energy is going to dissipate. Okay, there is some loss of energy. The ideal condition is there is no loss of energy, it will keep on oscillating for years and years and years, but of course that's just an ideal condition. In practical realistic world it won't happen. So damping is something which will have always in the practical reality. When we talk about the practical reality, we'll have the damping. So now let's talk about one of the topic which define the damping or which gives us the quantification that how much damping will be having after how much time that particular particle will stop, or after how much time that particular particle will have 70% of its original energy, or 35% or 12% of its original energy. Why so? Because we require these parameters to work it out with that particle. If I want to hit that particle when it is having the energy of 22%, but at what period after the start of oscillation it will be having 22% of energy, at what instant after the starting oscillation that will be having the 22% of energy. So all those kind of quantification can be done using this very important factor, which is the quality factor. Generally the concept is the ratio. This is the ratio of the same quantity, energy upon energy. So this is a constant, unitless constant, but very important at the same time. So the ratio of actual energy, the natural or actual energy it had, divided by the energy lost, the rate of losing energy or energy lost, and many different things are there. But generally, simply we can say it is the ratio of actual energy upon energy lost, actual energy divided by the energy lost. So if the loss of energy is more, quality factor will be less. If the loss of energy is less, quality factor will be more. Means it is still qualitative, it's still giving some efficient oscillation. If the almost 90% of energy is lost, quality factor will be almost 0.1, 0.2, 0.3 likewise. Hence it's almost drained like that. So this gives us the Q, the quality factor, which is denoted by Q, more often termed as Q factor. This gives us the actual picture that how the particle is moving right now, or how much energy the particle is associated with right now during its motion after the start. So okay, quality factor can also be written as mathematically, it can also be written as the natural angular frequency divided by the damping coefficient, which is B by M, or the coefficient of damping, which is B divided by M. Now what is B, what is M? We have discussed already in the while deriving that damping, mechanical damping. Now here क्या करेंगे ना, ये B square is equals to 4km, B square greater than 4km, B square less than 4km. ये जो critically damped, under damped और over damped का जो एक्सप्रेशन था, उसके पहले जो डिराइव्ड एक्सप्रेशन था वो कुछ 5-7-10 सेकंड के लिए स्लाइड पे ला देंगे, जस्ट टू रिफ्रेश के ये हाँ B by M जो है ये हमने देखा है, what does B stands for, what is M, etc. Therefore B by M क्या हो जाएगा? Okay, this is for you and this is the continuation of this second part. So what would be the B by M, students? It will be omega naught divided by Q. Now this omega naught is a natural frequency, but while damping, this is the damped frequency, this omega, or angular frequency you can say, angular velocity if it's rotating, but if it is oscillating then angular frequency, okay, which is 2 pi f, where f is the frequency of oscillation, which is inverse of time period of oscillation. All are interconnected. So this is nothing but under root of omega naught square minus B by 2m the whole square, isn't it? This we know. This is the frequency of a damped oscillator. Now we know what is B by M. That's omega naught divided by Q. So let's just substitute. So what it will be? Omega naught square minus B by M is omega naught by Q. So omega naught by q, and 2 is already there, so let it be as it is, the whole square. This will result into square root of omega naught square minus omega naught square once again divided by 4q square. Okay, let's take this common. So omega naught, it will come out as omega naught because it's coming outside the square root. It will be 1 minus 1 divided by 4q square, that is 4q square minus 1 divided by 4q square. This would be the very simpler form of this instantaneous frequency, we can say, or the damped or frequency of damped oscillator at particular instant with respect to or associated with this quality factor. Now we can have three cases of underdamped, critically damped, and overdamped. So when it will be critically damped, if this particular factor is 0, so if 4q square minus 1 is 0, implies 4q square is 1, implies q square is 1 by 4, implies q is half. Now we will say q can be plus or minus half. I agree, q can be plus or minus half, but we are taking that it is plus half. Okay, we are not considering the negative values just for a time being for critically damped situation. So let's say q is half. So this is for critical damping, critically damped. And what is underdamped, what is critically damped, and what is overdamped, we have discussed a lot on that. Okay, so यहाँ पे भी 5-7 सेकेंड्स के लिए वो पुरानी जो स्लाइड्स है जहाँ पे अंडर डैम्प्ड, क्रिटिकल डैम्प्ड और ओवर डैम्प्ड क्या था वो क्विकली दिखा सकते हैं 5-7-10 सेकेंड के लिए, और बाद में ये कंटिन्यूएशन में रहेगा. सो दिस इज द कंडीशन फॉर क्रिटिकली डैम्प्ड. नाउ इफ दिस q is equals to half is for critically damped, now it has to be under damped. So this particular root has to be positive. So when it will be positive, and 4q square minus 1 is greater than 0, implies 4q square is greater than 1, implies q square is greater than 1 by 4, and simply I am writing q is greater than half rather than having two roots plus or minus half. Let's say q is greater than half. When the quality factor is greater than half, so it is under damped. Okay, means quality factor is having high value. When the quality factor will have high value, conceptually, when the energy lost is very low. So consider 100% energy tha, so out of that 100% energy, only 10 or 20 or 30% energy has lost. So it's still having much energy so that it can bear or it can resist whatever opposition is there, and the things will move on continuously. But in the opposite manner, if it is over damped, that it is not having sufficient energy to resist the resistance. Are you getting the point? The opposition, the resistance which is coming externally, that particular system or object is not having much energy, then this particular value will be less than half. Let's see how, because for that 4q square minus 1 should be less than 0 for imaginary root. So 4q square is less than 1, implies q square less than 1 by 4, means q is less than half. Quality factor is not even 0.5, it's less than 0.5. So it means almost more than 50% of energy is lost. Now that particular particle or oscillator is not having much energy so as to sustain the opposition which is continuous. Okay, so this condition q is equals to half, which is very important for a critically damped situation. The q greater than half for underdamped, q less than half for overdamped. What is q? Quality factor. The concept is the ratio of actual energy divided by the energy lost. Okay, and that cantilever thing which we had in the raw content, that can be used for